Okay, so I know you guys love to prove identities, so let's prove these last three identities. We're going to start with A, and we're going to also state their restrictions. And I know you guys hate this part, but just bear with me. So if we look at this identity, any restriction that exists is if the bottom is equal to 0, okay? So this guy is not allowed to equal to 0, that guy is not allowed to equal to 0, and that guy is not allowed to equal to 0, because if it does equal to 0, then you're going to get something called an error or undefined, right? You're not allowed to divide by a 0, but you are allowed to have a 0 divided by something. This is no, that is okay. So these guys are not allowed to equal to 0. So if those come up at any point, then we end up having a little bit of a problem. Furthermore, we can expand on these two where cos x is not allowed to equal to, take the 1 across, become a minus 1, or cos x is not allowed to take this across, becomes a 1. So if cos x is equal to minus 1 or cos x is equal to 1, then we're going to end up having problems. Then this identity is not satisfied. Okay, but let's go first prove this identity. We want to simplify the one side versus the other side. So I'm going to take the left-hand side. We end up having 1 over, let's first identify, it's a fraction. So if we take our left-hand side, we need to identify that we've got a lowest common denominator. And our lowest common denominator is 1 plus cos x times 1 minus cos x, which is a beautiful, and if you can tell it before I say it, it's the same brackets. The only thing that's different in each bracket is a negative and a positive sign, so it's a difference of 2 squares. So when we look at this, that's our LCD, and to simply put, we're just going to multiply the top 1 with what's missing at the bottom. If I've got a 1 plus cos here, I'm missing a 1 minus cos x for that term. And I'm going to add it to 1 times, and everything is on my lowest common denominator, 1 plus cos x, close bracket, open bracket, 1 minus cos x. And at the top here, this ratio, this identity, ended up being 1 minus cos x. It's missing the plus. So we end up going 1 plus cos x. We distribute the top out, and we're going to get 1 minus cos x plus 1 plus cos x. These two end up cancelling each other, and we end up getting 1 plus 1 at the top, and we can keep the bottom as is for now. And the top simplifies to a 2. Now, how do we deal with the bottom? The bottom, I told you, was a difference of 2 squares. So if I had to write that out, I end up getting 1 minus cos squared x. And that's easy enough. This is that identity just rearranged. You're going to get 1 minus cos squared, leaves you with sine squared. So this becomes 2 over sine squared x. Quite an easy one, nothing actually too difficult. It's definitely a grade 11 level question. And now we need to restate all our restrictions. So we end up having sine squared x is equal to that, and we end up having cos x minus is not allowed to equal to minus 1, and cos x is not allowed to equal to plus 1. So how do we now apply those restrictions to this? We've proved that identity. How do we apply those restrictions? You just go and you state the restrictions like we did in the beginning. They're not allowed to equal to those. And then if we had to solve for it, you can end up finding your degrees. Okay, so we've completed proving that identity. We've stated the restrictions. Let's solve for those restrictions. Okay, we know, in this case, let's not write with an eraser, we know that cos x, if it was equal to 1, would not be a valid solution. So what would x have to be for it not to be valid? Well, if I get my reference angle, my arc cos, for 1, ends up giving you, let's show you, shift arc cos when it's 1 degrees, and that is equal to 0. So we end up having plus minus 0 degrees plus k times 360. If we have cos x is equal to minus 1, if you get your reference angle, you'll find out that it is 180 degrees. So it's plus minus 180 degrees plus k times 360. And if you take sine squared, x is equal to 0. If you square root of 0, you're still left with sine x. And if you arc 0, let's go show you, you end up going shift sine 0, you end up getting 0 degrees as well. So x is equal to 0 degrees plus k times 360, or remember, x is equal to 180 minus 0, which just leaves you with 180 degrees plus k times 360. So x is not allowed to equal to, and basically both of them prove those solutions. Question 10b, we've got sine 2p over 1 plus cos 2p is equal to tan p. I actually think we've solved this in this whole activity already before, but we know that tan p, as a restriction, any tan graph cannot go through a 90 degrees, it's undefined. So we already know that p is not allowed to equal to 90 degrees plus k times 180, okay? What we also know is that if this denominator is equal to 0, then we're going to have a problem. So this item here is not allowed to equal to 0. And those are our restrictions in this case. So let's go see how else we can simplify this to a point where we can actually solve for this item. We can do our restrictions first before solving. So if we look at this, we end up having 1 plus cos 2p, which is equal to 0. We can take the 1 across, which is cos 2p is equal to negative 1. And no matter what the angle is, if you put in a arc cos negative 1, you will always get 180 degrees. So our restriction here ends up becoming 2p is equal to plus minus 180 degrees plus k times 360. But I want to know what p is, so I divide everybody by a 2. Therefore, p ends up being plus minus 90 degrees plus k times 360. And there's our restrictions for p. So let's prove this identity, though. Our left-hand side is definitely more difficult than the right-hand side. Our right-hand side, if I can get this to look like sine p over cos p, then I've won. So let's get our left-hand side to look like our right-hand side. Sine 2p ends up becoming 2 sine p times cos p. And think about it. I need to keep a cos at the bottom and I need a sine at the top. So I need to be able to not cancel out the sine. So let's try and keep everything at the bottom, possibly a cos. And the only way I can do that is by using the double angle that's related to that guy over there. So we end up going 1 plus, and let's keep that color the same then. We open that up to 2 cos squared p minus 1. And there we end up having our identity being swapped out. And if we get rid of the brackets, we can take this one and minus that one from it. So we're left with 2 sine p times cos p at the top And as our denominator, we end up having 2 cos squared p. And I can simplify that down by cancelling the 2's out because they're dividing by each other. So this 2 divides by that 2. And I can simplify this cos p with this cos squared p. There's 2 of them here. I can take the 1 away, which means I am then left with sine p over cos p, which is the same as tan p. Our left-hand side is equal to our right-hand side. That was a nice identity. Okay, so our next identity is question 10c, and we've got cos 2a over 1 plus sine 2a is equal to 1 minus tan a divided by 1 plus tan a. Now, remember, our denominators are not allowed to equal to 0. And if they are equal to 0, then this whole item will be undefined. So, in this case, 1 plus sine 2a is equal to 0. Take the 1 across, you end up having sine 2a is equal to minus 1. And then you end up doing your general solution. So you end up having 2a is equal to, and our angle for sine, shift sine, minus 1, minus 90 degrees. So that becomes minus 90 degrees plus k times 360, or it ends up being 2a is equal to 180 minus 90 degrees plus k times 360. And this ends up being a is equal to minus 45 degrees plus k times 180. And this becomes a is equal to 180 plus 90 gives me 270. And half of 270 is 135 degrees. Plus k times 180. Those are the 2 items for the sine, and if we have to restrict our tan, 1 plus tan alpha is not allowed, a is not allowed to equal to 0, so tan a is not allowed to equal to minus 1. If we want to find out what our tan is, arctan shift tan negative 1 equals minus 45 degrees. And we know that this identity then becomes a is equal to minus 45 degrees plus k times, not 360, it's the tan general solution, so it's times 180 degrees, which is exactly the same as that, which is why they're allowed to equal to each other on the other sides. Okay, so we've proven our restrictions, what our angles are not allowed to equal to. If they do equal to those angles, then the solution will not be valid. But let's go try to prove that identity. Okay, we've got a clear screen. Let's now prove our identity. Our right-hand side is, I think, more easy than our left-hand side because we've got our double angles. Let's see if we can get to this point. Please note that this side does end up probably needing to be simplified, but let's try to do the left-hand side and see how far we get. Okay, so left-hand side, we end up having cos 2a. Now cos 2a over sine 2a. I'm going to do the bottom first, just so that you can see what we've got here. 1 plus 2 sine a times cos a at the bottom. And I know that I'm going to have to rearrange this side anywhere. Okay. I know that I end up having a sine at the bottom and a cos, and then I'm going to end up changing this cos 2a, but I'm not too certain what I need to change this cos 2a to. And I could guess, and I could take a couple of guesses, but I think what I'm going to do is I'm going to try simplify the right-hand side a little bit to see if I can actually get a hint on how to get to my, which which ratio I need to use at the top to simplify. Okay, so if we take our right-hand side, we've got 1 minus tan A, which is the same as 1 minus sine A over cos A. All divide that by 1 plus sine A over cos A. If I change this into a fraction, I can end up having a lowest common denominator here. This 1 can become a cos over a cos. So this ends up becoming cos A minus sine A all over cos A. That's just that top part there. Then I've got my original divide line, and this becomes cos over cos, so it becomes cos A plus sine A all over cos A. Okay, this divide line means that I can take these two together and I can tip and times them. So I can have cos A minus sine A all over cos A, tip and times with, so we're going to bring this up here, it's divided by, now we're going to flip it and times it, cos A over, not that, cos A plus sine A. Which means I can cancel out those guys and I end up having cos A minus sine A all over tops times tops, which is cos A minus sine A times the 1 here, because that's been simplified by that, over cos A plus sine A. I think that's easier to do for us to get to a point where we need to figure out what we're going to do over here. So I've got cos A plus sine A at the bottom, and that gives me a hint over here. I've got 2 sine A plus cos A, and I've got a plus 1. I know that this plus 1, I can use this ratio over here. I've got a middle term, and I can add in my cos squared and my sine squared at the bottom. So I can factorize this then, which means I need to be able to factorize the top. Okay, and the only way I can factorize the top and keep the top with a cos A minus sine A is if I end up using this ratio, this top ratio, cos squared A minus sine squared A. That ends up giving me a difference of 2 squares. So that's why I'm going to do that. I'm going to keep it as cos 2A just now because I don't think you guys understand what I'm trying to say, and I'll get there. So we end up having cos 2A over 1 plus 2 sine A plus cos A. When I see this in factorizing scenarios and I can't go any further, it sometimes means that this needs to become my middle term. So I need to have a cos somewhere and a sine somewhere to be able to get this to be a middle term. So if I go and I write that out, my 1, I'm going to have 2 sine A times cos A as my middle term. And my 1 ends up being changed to this ratio. I'm going to make it green. My 1 is equal to cos squared A added to sine squared A. Quite easy, okay? When I'm dealing with factorizing the bottom, I end up creating my 2 brackets and do large brackets because you're working with trig. This is a perfect square. You should know that by having a square of the first, a square of the last, and those are the values in the middle and they doubled. So you should be able to see that this becomes cos A, and the signs are all plus, times sine A, plus cos A plus sine A. So we're at this point in time for the bottom, and we're happy to get to that point. Now I want to go do this cos 2A. And the way that I can do this cos 2A is I can sit there and I can change it to, where's my yellow? I can change it to cos squared A minus, that's not a minus, minus sine squared a. And now at the top, I have something that we call difference of two squares. Now I've got my difference of two squares at the top. So I can create the exact same brackets. I can then square root the first and put them in the first position. I can square root the lasts and I can put them in the lasts position. And each bracket gets a different sign. And that is all over what I just did before, the cos A plus sine A. It's our perfect square, right? Cos A plus sine A. And now I can simplify these ratios. I can sit there and I can see there's a cos A plus sine A, there's a cos A plus sine A. Here's a cos A minus sine A and a cos A plus sine A. Because of the different signs there, I'm not allowed to simplify it. And now we've gotten to a point where we see that our left-hand side is equal to what we devised on our right-hand side. So both of these had to work towards simplifying. You could have gotten to this point, and then if your brain works like this, you could have then decided to times it by a value of 1, which is the same as the denominator. You would have ended up getting cos A plus sine A times cos A plus sine A. And you would have realized that this multiplied together gives you this difference of two squares. You would have gotten this item, FOILed out this item, and you would have gotten this term, and then you would have added those together to get the 1. So you could have actually gone from this point and reversed your way up back that way. But I find that a lot of you struggle with that kind of process. So mostly, if you can't simplify the right-hand side far enough and you get stuck there, then work on the left-hand side so that the left-hand side does equal to the right-hand side. I hope that was helpful. That is the last question in this Check Your Skills. Please, you should have done all these questions by yourself. This is just to help you, guide you so that you can understand how to answer these questions and where you've gone wrong. Go look at your work, see where you've gone wrong, practice your stuff, and good luck for your tests.